Hi, I'm Luke Kay. Welcome back to Algebra 1. Today we're going to talk about complex fractions. What's a complex fraction? Well, it's a form that looks like this, where we have a over b over c over d. Essentially, that's a fraction over a fraction. Since we're in an algebra course, each of those, the numerator and the denominator, each of those are a rational expression. That is, they are a polynomial of some sort. But it doesn't matter, because it turns out the way to the way to operate with a complex fraction is the same, whether it's an arithmetic complex fraction or an algebraic complex fraction, as we'll see in a second. So basically the trick to dealing with complex fractions is to reduce them to a division problem. So we take our complex fraction and we realize that the numerator is actually the dividend, right? Because basically what this says is we are dividing the numerator by the denominator. So that means the denominator is the divisor. Well, once we reduce this to a division problem, we've already solved this. And the trick to operating a division problem, to doing division, is just to copy the dividend, change the sign to multiplication sign, and then flip the divisor. Then once we do that, multiplication's a breeze. We multiply numerators times numerators, a times d to get ad, and b times c to get bc. Okay, let's try a couple of problems. Here we have two complex fractions. The first complex fraction is right out of an elementary school textbook, or it could be. Basically, it's a fraction divided by a fraction. Nothing earth-shattering there. And the second one, labeled b here, well, that's a rational expression divided by a rational expression. Both of them are complex fractions, and both of them can be quickly manipulated. And basically, let's show how to do problem number A. When we look at this complex fraction, fraction over fraction, what we really mean is that that is equal to a dividend, which is the same as the numerator, divided by the denominator, which becomes the divisor, 15 over 28. And we've reduced this to something we already know how to do. We know when we have a dividend divided by a divisor that are fractions, we take the dividend, which is 10 over 21, we leave it as it is. We change the division sign to multiplication, and now we flip. We bring this up here, make that 28, and we bring that down here, 15. And now, because the only operation we have involved is multiplication, all of these numbers are factors. And since they're all factors, we can now start doing some factoring. We can take 5 and factor into that. 15 divided by 5 is 3. And 10 divided by 5 is 2. 7 goes into 21 3 times. And 7 goes into 21 4 times. And now we do division as we were taught back in elementary school. We multiply numerators by numerators. We get 2 times 4, 3 times 3. 2 times 4 is 8. 3 times, that's 3 times 3. Alright, so now we do the arithmetic as we were taught back in elementary school. 2 times 4, that's the numerator. Right, we're multiplying numerators, and now we multiply across the denominators. We get 3 times 3. 2 times 4 is 8. 3 times 3 is 9. Alright, let's do the slightly more complex one. And it's the same deal. The numerator is a dividend, 4k plus 1 over 12. That's a dividend. And it is divided by a divisor that is 16k squared minus 1 over 18. Alright, so now we're going to change this into a multiplication problem. Alright, we leave the dividend intact, change the division sign to multiplication, and now we're going to flip. This is going to go up, So the the denominator becomes the numerator, and this is going to go down. So we get 16k squared minus 1. All right, well, we now have this. If we think of this as a binomial and this is a binomial, we now have factors where everything's being multiplied by everything else. As long as we don't look inside the parentheses, we're okay. So maybe we can factor this. Well, we can factor this, right? This goes away. Well, it doesn't go away. 6 goes into 12 twice. 6 goes into 18 3 times. Okay, 4k plus 1. Well, I can't do much with that, at least not yet. And that's over 2 times 3. This is difference of squares. So this is going to be, oops, getting ahead of myself, going to be 4k plus 1, right, times 4k minus 1. All right, everything still factors, so we can still do some factoring. That's going to factor out. And what are we left with? We're left with 3 over the quantity 2 times 4k minus 1. Very straightforward. What did we learn today? Well, we learned that a complex fraction is nothing more than a fraction over a fraction, and that to deal with it, to do the operation, that a complex fraction can be reduced to a division problem, where we recognize that the numerator is in fact the dividend of division problem, and the denominator is the divisor. Once we realize that, then we just change the sign, flip the divisor, and then do the multiplication across numerators and across denominators as such. Fairly straightforward. Well, I'm Luke Kane. Thanks a bunch for watching. Bye now. What did we learn today? Well, we learned that a complex fraction is nothing more than a fraction over a fraction, and that to deal with it, to do the operation, that a complex fraction can be reduced to a division problem, where we recognize that the numerator is in fact the dividend of a division problem, and the denominator is the divisor. And once we realize that, Then we just change the sign, flip the divisor, and then do the multiplication across numerators and across denominators as such. Fairly straightforward. Well, I'm Luke Kane. Thanks a bunch for watching. Bye now.